Hey everyone, I hope you're all doing good. Today is going to be the last lesson of relations and functions. And really, there's just kind of a couple little concepts that we have to knit together to finish the unit. We're going to talk today about rate of change. We're going to talk about building equations. We're going to talk about graphing equations. And we're also going to talk about finding x and y intercepts, okay? So it's kind of a bunch of little lessons all in one to kind of wrap up the unit. Okay, so first of all, let's start here. The following table and graph represent the cost of a pizza versus the number of toppings. What patterns do you see in the table? So what we want to do is look at the table and see what's happening. So I see that the number of toppings are going up by 1 each time. And I see that the cost of the pizza is actually going up by 75 cents each time, okay? I start at $12 and then I add 75 cents when I get an extra topping. I add another 75 cents when I get another extra topping, and so on and so forth, okay? So the X's are going up by 1s, and the Y's, the cost, is going up by 75 cents each time, okay? So as the number of toppings increases, the cost of the pizza increases. The cost starts at $12 for no toppings, no extra toppings, really, I should say there, and then increases by 75 cents for each topping added. Okay, so write a rule for the pattern that relates to the cost of the pizza to the number that relates the cost of the pizza to the number of toppings. Now, essentially, we're going to write an equation, and any sort of linear equation, what I want you to think about is the cost is going to equal the cost per topping plus the cost of nothing. Okay, so the cost per topping is 75 cents, but you have to write that as a dollar amount. So that'd be 0.75 per topping. That means for every X that I go up, I have to add another 0.75 cents. So we're going to represent that as the number of toppings we're going to call N. And so that would be 0.75 N, because it would be 0.75 times the number of toppings I have, plus the cost of nothing. The cost of nothing, or the cost of no extra toppings in this case, is $12. So I end up with C of N, so I'm writing this in function notation. C, I'm naming the function C for the cost, and then N is the number of extra toppings. So C of N equals 0.75 N plus 12. So this is my cost per topping, and then this is my cost of nothing, okay? Or cost of 0, or initial cost. You'll hear all of those things said as we kind of dive through here. Okay, how are the patterns in the table shown in the graph? Well, we know that every row on the table becomes a point on the graph, right? But what we're looking for here is patterns. So what I want you to notice is just follow the dots, okay? X is going up by 1, and Y is going up by 0.75. You can still see that in the dots, the way the graph is shown, okay? I also want you to see that when we see it visually, the dots are actually, we're not going to connect them, and we'll talk about why we don't connect them, but what I want you to see there is they form a straight line, okay? Even though we're not connecting the dots, the pattern of the dots is still a straight line. Sorry, that took a lot for me to get out there. I was trying not to say they form a line because I don't want you to think that they're continuous data, but the dots themselves are going in the shape of a line, okay? All right. Oh, sorry, I need to put my mouse back on here. Okay, each row in the table becomes a point on the graph. The first row is 0 toppings and a cost of $12. This becomes the point 0, 12 on the graph. And then I can see the X's are going up by 1s and the Y's are still going up by 0.75. Okay? All right. How can you tell from the table that the graph represents a linear relation? Well, I actually already answered that question. I can see that the number of X's are going up by the same amount and the number of Y's are going up by the same amount. So the same amount is added to the total cost for every topping that is added. Now, the key word here is the same amount, okay? If I added 0.75 here, and then I added 0.8 here, and then I added $1.05 here, that's not going to be a straight line anymore. That's not going to form a linear relation, okay? Okay. Why are the points not connected? What kind of graph does this show? I'm hoping you're getting comfortable with a question like that now, because I've asked it in the last couple of lessons. The points are not connected because you can't have half a topping, right? Either you get a topping or you don't get a topping. And then that shows discrete data is the word I'm looking for there, okay? The data is discrete, not the date. That would be a mistake. The data is discrete, okay? So a linear relation is a direct relationship between two variables. When graphed, a linear relation will look like a straight line. And it will have what we call a constant rate of change. Now we're going to talk about rate of change here for the next little bit and how to calculate it, okay? The rate of change means that your x's are going up by the same amount and your y's are going up by the same amount, okay? So which of the following tables represent linear relations? So I'm looking for a constant rate of change. Well, my x's here are going up by 1, so that's cool. My y's are going up by 2, 2, 2, 2, 2, 2. So there is a constant rate of change here. So it's linear. X is going up by 1 and y is going up by 2. Okay. The next guy, if I take a look, I'm going to look at my x's first. Go up by 20, go up by 20, go up by 20, go up by 20, go up by 20. So that's cool. Let's look at my y's. Go up by 1, go up by 2, stop. It doesn't work. Okay, this is not a constant rate of change. As soon as it goes off kilter, you know for sure it's not linear. Okay, so it's not linear. X is going up by 1, but y is not a constant change. Okay, so now we'll take a look at this guy. I'm going up by 5, 5, 5, 5, 5. 32 to 41, I'm going up by 9, going up by 9, going up by 9, going up by 9, going up by 9. So that's cool. There is a constant rate of change there. So that is linear. And then the last guy, going up by 1, 1, 1, 1, 1, 1, going, well, no, for sure this is not, right? Here I'm going down by 15 and then I'm only going down by 1. So that is not a constant rate of change, and so it is not linear. Okay? Hopefully that makes sense as we've gone through those examples. Okay, so how do I calculate rate of change? Rate of change is calculated by taking the change in the dependent variable and dividing it by the change in the independent variable. Now remember, the dependent variable is y, and the independent variable is x. So to get the change, what we're doing is we are taking two y values and subtracting them, and that will tell you the change in the y values. And then take the same two x values, like the ones that correspond to the y values you just used, and subtract them, and that will tell you the change in x. And then you just divide the two, okay? So we'll get into actually calculating that in a minute here. The following table and graph represents the cost of renting a vehicle per kilometer driven. What is the vertical intercept and what does it represent? So the vertical intercept refers to where I hit on the vertical axis. That's also known as the y-axis. And it's also known as the spot when x is 0. So I can see that on my table here, okay, or I can see that on my graph here. Either way, the vertical intercept is 0, 60, 0, 60. And that essentially represents the cost of nothing, okay? I have not driven this car at all. It's for 0 kilometers, and I have to pay 60 bucks. So all I've done is I've signed the paperwork. I said I'm gonna rent the car. I might be even sitting in the car, but the car has not moved. 60 bucks just to rent the car initially, okay? Okay. What is the rate of change and what does it represent? So what we're gonna do is we're gonna pick 2 points. I'm gonna pick them off the table just because it's easier to read than the graph. My graph is a little small and blurry here, but I'll just take them right off the table. It doesn't matter which 2 points you pick. You can pick any 2 points you want, okay? So I have chosen the point 0, 60, which I've circled, and I've chosen the next point, which is 100, 80. So I've gone change in y, well, that's 80 minus 60. That's my change in y. and then change in x for the same two data points. So that'd be 100 minus 0. The other thing that's important there is that you go in the same order that you started with. So because I started with the 80, I had to start with 100 for my x. Okay, so 80 minus 60 over 100 minus 0. 80 minus 60 is 20. 100 minus 0 is 100. 20 divided by 100 is 0.2, or 20 cents a kilometer. So it represents the charge per kilometer driven. Okay, so the cost of renting this car is 60 bucks and then 20 cents for every kilometer you drive. Okay. All right, can you create an equation for this graph? Now remember, we're gonna create it roughly the same way as we did on the last one with the pizza. I said that it's gonna be the cost of nothing plus the cost per item. Okay, so in this one, it's the cost per kilometer, and we've already discussed that, that's the rate of change. So we're looking at 0.2 D or X, whatever you wanna call the per kilometer, okay, plus the cost of nothing, which is 60. So my equation is C of D. I use D as my input variable for distance driven, and C is my output variable for the cost, okay? So I have 0.2 times the amount of kilometers driven plus 60 bucks, okay? Now, each one of these I have in a different color because I want to define what each of these are. Every linear equation that you create can be created in the same sort of scenario, okay? So this guy is my dependent variable. It's always the dependent variable equals. This guy is my rate of change, and the D was my independent variable, and then my 60 was my initial amount or my initial cost or my cost of nothing, okay? So every equation that's linear that you set up is going to be set up this exact same way. The dependent variable equals the rate of change times the independent variable plus the initial amount, okay? Okay, now intercepts, we have two intercepts that we talk about. We talk about the horizontal intercept and the vertical intercept. The horizontal intercept is also known as the x-intercept, and it's where the graph intersects the horizontal axis. Now, I'm going to draw for you a few x-intercepts, and we're going to make a guess at what each of those points might be, okay? So this guy here, I'm gonna say that might be -4, 0. And this guy here might be -2, 0. And this guy here might be 3, 0, okay? So first I want you to agree with all of those points, that those are okay points, the way I've set up this graph. But second of all, what I want you to see is if I'm on the x-axis, if I am an x-intercept, the value of y is 0, because if I'm on the x-axis, I have not gone up or down from the x-axis. So the value of y will be 0. That is a really important point as we continue this little journey together, okay? The vertical intercept, also known as the y-intercept, and that's where the graph intersects the vertical axis. So if I gave you some y-intercepts here, okay, you might call this guy, think about it before I do anything, okay, maybe 0, 5, and this guy maybe 0, 1, and this guy maybe 0, -6, okay? And what I want you to see there is if I'm on the y-axis, the value for x is 0, because I have not moved left or right from the y-axis, okay? So remember that all coordinate points always go x, y. So if I'm on the y-axis, the value for x is 0, whatever the y value is. And then if I'm on the x-axis, it'll be whatever the x value is, 0, because it's always the other guy that's 0. So if I'm on the x-axis, the value of y is 0. If I'm on the y-axis, the value for x is 0, okay? All right, so this graph shows the fuel consumption of a scooter with a full tank of gas at the beginning of a journey. Write the coordinates of the points where the graph intersects the axis. Determine the vertical and horizontal intercepts. What do these points represent? Okay, so we'll start with the vertical intercept or the y-intercept. That's at 0, 8. What that means in the context of this question, you always have to relate it back to the context of this question. I have not driven any kilometers if it's 0. And 8 would be, that's how much gas is in my tank at the beginning of my journey, okay? So at the start of the journey, the scooter has 8 liters of gas. the horizontal intercept, or the x-intercept, is 200, 0. And what would that represent? Well, I've traveled 200 kilometers and I'm out of gas. So there was no gas left in the tank when the scooter rode 200 kilometers. It is super important that when you are asked for an intercept, intercepts are always points. Okay, so bracket x comma y bracket, always coordinate points when you are asked what an intercept is. Okay. All right, what are the domain and ranges of this function? So the domain, I'm going from 0 to 200, and I can be a member of the reals. Range, I'm going from 0 to 8, and I can be a member of the reals. Okay. What's the rate of change? So pick 2 points. Well, I have 2 very obvious points here, right? I've got the point 0, 8, and I've got the point 200, 0. So maybe I'll use those to get my change in y over my change in x. Remember, the rate of change is your change in your dependent divided by your change in independent. So I've gone 0 minus 8 over 200 minus 0. And what I want you to notice there is that actually gives me a negative, and that makes sense because the negative refers to the fact that the volume is decreasing. Okay, so it's negative 0.04 liters per kilometer. Rate of changes have to have units with them. Okay, in the next lesson, which starts the next unit, we'll talk about slope. And the fundamental difference between slope and rate of change is that slope doesn't have units and rate of change does. Okay, so rate of change is negative 0.04 liters per kilometer. That means every kilometer I drive uses 0.04 liters of gas. Okay, now the next little section here is we're going to create a table of values for each of the following equations. Then graph the following equations in your graphing calculator, which are linear and how do you know? Well, we're just going to draw the graphs by hand. Now, anytime you create a table of values, you just decide what values for x you want your input to be. Okay, so that part is a little bit random. I've given it to you. I've just said let's go from -2 to 2. Okay, you choose what your inputs are, and then you plug it into your equation and get out your outputs. Now this one's kind of special, like my mama told me I was, because in the actual equation there is no x value. What that means is it doesn't matter what the x value is, the y value will always be 2. So when I create my table, it's just 2, 2, 2, 2, 2 along the y's. Now, when you go to graph that, remember you're reading across the rows to get the point. So I'm going to plot the point -2, 2. I'm going to plot the point -1, 2, 0, 2. And what happens is I get a horizontal line. Now, some of you may recall in an earlier lesson, I said if all you're given is a table, you can't connect those dots. I want you to understand the difference here. You are actually not given the table here. You are creating the table. You were given an equation. And when you're given an equation, you understand then that that's a member of the reals. That's not discrete data. Equations are not discrete data unless you're specifically told that they are. Okay. Now, that is a line and it is a function. So what we do is we call that a linear function because it's in a straight line and it passes the vertical line test. It is both linear and a function. So we call it a linear function. Okay, next guy. Again, I'm just looking at my inputs from -2 to 2. You could have chosen anything. I'd like to have a couple negative and have a couple positive. I'd like to see what's going on around 0, and that's why I did that. You're going to plug those numbers in for x and solve for the corresponding y values. Good time to pause me. Okay, and then you should have gotten 2, 4, 6, 8. Who do we appreciate? Math. No, 2, 4, 6, 8, 10. When you plot those, you should get a graph that looks something like that. Again, this is linear and it's a function. So we're going to call this a linear function. Okay. All right. Next guy, y equals x squared. So again, I'm choosing -2, -1, 0, 1, 2. Plug those in. You're going to get 4, 1, 0, 1, 4. So I want you to see right away, before I even show you a graph, this cannot be called linear, right? I have changed direction. I was going down in my y's, and then I hit 0, and I start going up in my y's. So this is not linear. When you graph it, you should get a graph that looks something like this. This is still a function, but it's not linear. So we call it a non-linear function, okay? A non-linear function. Okay, check out this guy. Okay, so you can't take the root of -2 or -1, so those don't exist. The root of 0 is 0, the root of 1 is 1, and the root of 2 is around 1.4. When you go to graph that, you'll get a picture that looks something like this. We'll talk a lot more about those guys in grade 11 and 12. They're called radical functions. This is not linear, but it is still a function. So this is a non-linear function, okay? All right, and then x equals 4. That means no matter what y is, x is 4. So notice how the table changed. I just put 4 in for x because it doesn't matter what I put in for y. X is always going to be 4. Okay, and when I go and graph those points to try and see what I'm looking at, I see that I end up with a vertical line. Okay, now this is linear, but it's not a function. Okay, it's not a function because it doesn't pass the vertical line test. It is a vertical line. A vertical line can't pass the vertical line test. So I can't call it a function. I have to call it a relation, but I can call it linear. So this is a linear relation. Okay, so the other thing I want you to notice in this little section of our notes is if I have an equation that says y equals a number with no x, that's always going to be a horizontal line. And if I have an equation like this guy, which says x equals a number with no y, that will always be a vertical line. Okay, so that's just helpful for you to keep in mind. All right, so then the last portion of this note, we're just going to practice algebraically figuring out x and y intercepts. Now remember the conversation I had with you up here. If I am an x-intercept, the value for y is 0. So all I have to do is substitute my y value with 0 and solve for x. Likewise, if I'm looking for the y-intercept, the value for x is 0, so I can substitute 0 in for x and solve for y. Very important that you label which one is which. So the very first thing I'm going to do is tell my teacher what I'm doing. I'm going to solve for the x-intercept, and I do that by letting y equals 0. The other dude is always 0. So if I'm looking for the x-intercept, the value for y is 0. So here I go, plugging y in as 0. And now I'm going to solve, so I'm going to add 6 to both sides, and then I'll divide both sides by 2, so I get x equals 3. Now remember my little preaching moment a couple slides ago, intercepts are always labeled as coordinate points, so it's not enough to just say x equals 3 here. I want to know the actual point, which would be 3, 0. Okay, then if I want the y-intercept, I'm going to let x equal 0. So I substitute x as 0, 2 times 0 is 0, and then subtract 6, I end up with -6 for y. I have to write that as a coordinate point, so that would be 0, -6. Okay? So another way to draw graphs is you could find the intercepts, plot those intercepts, and then just connect them instead of finding the 5 or 6 points I got you to find on the last guy. Okay? There's a bunch of different ways you can go about trying to draw out lines. Okay. We're going to try the x and y intercepts a couple times. So this is, now that I've gone through one example with you, I want you to pause me and try these guys on your own, and then come back and check your work with my work, okay? Okay, so again, to find the x-intercept, I'm going to let y equal 0, and now I'm going to solve for x, so I'll subtract 27 from both sides and then divide both sides by -3. That gives me x equals 9. So then my x-intercept is bracket 9, 0. Intercepts are always written as coordinate points. To get my y-intercept, I'm going to let x equal 0. So I plug 0 in for x and solve and get out 27. And so that point would be 0, 27. Okay? Next guy. Doesn't matter that this is in a different format. You're going to do the exact same thing. So pause me. Okay. So welcome back, by the way. So to get the x-intercept, I'm going to let y equal 0. So I'm going to substitute my y as 0. That essentially knocks out 20 times 0 is 0. So I'm left with 5x equals 5. Divide both sides by 5, and I get x equals 1. So the point there is 1, 0. And then to get the y-intercept, I do the same thing, but I let x equal 0. Remember, it's always the other guy equals 0. So 5 times 0 is 0. That leaves me with 20y equals 5. Divide both sides by 20, and that will give me a quarter. 5 over 20 reduces to 1 over 4. Don't write that as a decimal. fractions are fine. Fractions are always better than decimals. Okay, so the point there is 0, 1/4. Okay, try this guy. So to get the the x-intercept, I'm going to let y equal 0, plug 0 in for y. I get 4x equals 48, divide by 4, and I get x equals 12. So my point is bracket 12, 0 for the x-intercept. The y-intercept, I'm going to let x equal 0, which gives me negative 24y equals 48. Divide both sides by negative 24, and I get y equals negative 2. So the point there is 0, negative 2. Okay, awesome. Okay, try this guy. So again, to get x-intercept, I'm going to let y equal 0. That gives me 2x equals negative 12. I also brought the 12 over, and now I'll divide both sides by 2 and get x equals negative 6. So that point is negative 6, 0. And then for the y-intercept, I'm going to let x equal 0. I still have to bring the 12 over like I did with the other guy. So that'll give me negative 3y equals negative 12. Divide both sides by negative 3, and I would get y is 4. So that point is bracket 0, 4. Always, always, always write your intercepts as coordinate points, okay? All right, try this guy. Again, if I want the x-intercept, I'm gonna let y equal 0. Plug that in, and I have to bring my negative 30 over, so I get 3x equals 30, divide by 3, and I get 10. So that point, the x-intercept is 10, 0. And then if I want the y-intercept, I'm gonna let x equal 0, bring my 30 over, and I get negative 5y equals 30. Divide by negative 5, so I'll have y equals negative 6, and that point is 0, negative 6. Okay, so that ends our unit together. Hopefully, again, this is feeling okay. If it's not, make sure, well, either way, make sure you're doing your homework, make sure you're doing your practice questions, and make sure you connect with me if you have any further questions, because I'm here to help. Okay, you got this. Okay, we'll talk to you soon. Take care, guys.